Hello, welcome to Basic 2 Tech for students, teachers, and math education. Today's video is a continuation of our last video on differentiation from first principle. If you missed our last video, please click on the link at the top right corner so that you can understand the basic foundation as it relates to this topic. So just a quick flashback. The formula we are using, or the method we are using for differentiation from first principle, is the limit as h tends to 0, f of s plus h minus f of x over h. This is the formula we're using to solve differentiation from first principle. And please, one thing you must note here is that anywhere you see s in the function, x is the same as equal to x plus h. This s plus h is equal to f of x plus h. So what we do is to substitute this part of the equation to this. If, for example, we have x squared, it becomes s plus h all squared. So if, example, we have 2x, 2x becomes 2, open bracket, the s becomes x plus h. This is equal to this. So let's look at two more questions on this topic. So here is our first question. We have to find the derivative of f of s equal to 2s plus 1 using differentiation from first principle. What we do again, remember our formula is the limit, or is limit as h tends to 0, f of x plus h minus f of x over h. All right. So remember again, what you have right here should be f of phi of x equal to. So this is our given function. And please remember that we have 2x plus 1, 2x plus 1, 2x is the same as saying 2, open brackets, x plus 1, that's it. Then plus 1, so we have 2x plus 1 becomes 2, open brackets, x becomes x plus h, sorry, here should be h plus 1 plus 1. So this equation is equal to f of sh plus 1. So this is equal to f of s plus h. So we have to replace this whole equation by this. And f of x is 2s plus 1. So therefore, our equation becomes limits of as h tends to 0. So I will replace this with 2 open brackets s plus h plus 1 minus f of x is this, which is 2x plus 1. So it's 2x plus 1 over h. So the next step is to simplify the numerator. So therefore we have limit as h tends to 0. 2 times x is 2x. 2 times plus h is 2h plus 2h plus 1 minus 2x plus 1. 2x plus 1 over h. So the next step here is to further simplify the numerator. As you can see, we have like terms. For example, we have 2x, we have 2x, we have 1, and we have plus 1. So what we do next is to simplify further the numerator. So what we do is to group like terms. So we have limits as h tends to 0. So we have 2x minus 2x. So we have 2x minus 2x. We have plus h. We have plus 2h, plus 2h. Then we have plus 1. We have plus 1. Minus, plus is a minus, so we have minus 1. Minus 1. So over h. As you can see, 2s minus 2s gives us 0. Plus 1 minus 1 gives us 0. So we are left with 2h over h. So therefore we have limits as h tends to 0. We have 2h over h. Here h cancel h. So we are left with 2. So this is our final answer. So therefore we can say that the derivative of 2x plus 1 is equal to 2. So 2 is the derivative of 2x plus 1. Let's look at our next question. Here we asked to find the derivative of 3x squared plus 2x plus 1. Again, remember the formula is f prime of x is equal to the limit as h tends to 0, f of x plus h minus f of x over h. Now, we have to work on this right here. So, 3x squared, remember guys, 3x squared plus 2x plus 1 can be written as 3. S becomes x plus h or squared plus 2. 2, s becomes x plus h, then plus 1. This new equation is equal to f of x plus h. So what we do is to replace this equation with this. So therefore, we have limits as h tends to 0. I will place this equation right here with this. So we have 3 open bracket s plus h or squared plus 2 times x plus h plus 1 minus f of x is 3s squared plus 2s plus 1. So it's 3x squared plus 2x plus 1 over h. We missed our last video to expand s plus h squared. What we do is to s plus h squared is equal to s plus h times x plus h. So s times x is x squared, x times h is plus xh, plus h times x is plus xh, plus h times plus h is plus h squared. So we have x squared plus sh plus sh is 2sh plus h squared. So s plus h all squared is equal to s squared plus 3sh plus h squared. So I will replace this, whole equation with s squared plus 2sh plus h. So therefore, we have limits as h tends to 0. We have 3 open bracket, replace s plus h all squared with x squared plus 2sh plus h squared plus 2s plus h plus 1 minus 3x squared plus 2x plus 1 over h. So what we do next is to open up this bracket, or we can say we have to simplify further what we have in the bracket. So we now have limit As h tends to 0, 3 times s squared is 3s squared. 3 times plus 2sh is 6sh is plus 6sh. 3 times plus h squared is plus 3h squared, plus 2 times x is 2x, times plus 2 times plus h is plus 2h. Then we have plus 1. Now, this minus, we multiply everything on the right. So minus 3s squared, here we have minus 3s squared. Minus times plus is minus, so we have minus 2x. Minus times plus is minus 1. If you want to know how to multiply signs, you can please click on the link on the card above so you can learn how to do that. So over h. So the next step now is to further simplify the numerator by grouping the like terms. As you can see, we have 3s squared here, we have 3s squared here, we have plus 2x, we have minus 2x. So we have to group the like terms. So we have limit as h tends to 0. So we have 3x squared minus 3s squared. This is called grouping. Then we have plus 2x minus 2x. So we have plus 2x minus 2x. Again, we have 6 plus 6sh. We have plus 3h squared. We have plus 2h. We have plus 1. We have minus 1 over h. This, what I've just done on the numerator, is called grouping of like terms. If you want to learn how to group like terms, you can leave a comment in the section below and I will make a video on that. So 3s squared minus 3s squared, this gives us 0, plus 2x minus 2x is 0, plus 1 minus 1 is 0. So what we have on our numerator is 6sh plus 3h squared plus 2h over h. So therefore, we have limit as h tends to 0. We have 6sh plus 3h squared plus 2h over h. Now, what we can do here is to simplify the numerator, or let me say we can factorize. As you can see, we have h on each term, so I can bring out h and open bracket. H divide 6sh is 6x plus h divide 3h squared is 3h plus h divides 2h is 2 over h. As you can see right here, h cancel h. So what we have left is limit as h tends to 0 is, we have 6x plus 3h plus 2. Now, our last step in doing this is to substitute h for 0. So if h is equal to 0, so we have 6x plus 3 times h is 0 plus 2. So that gives us 6x plus 3 times 0 is 0, so we have plus 2. 3 times 0 is 0, so we have plus 2. So therefore, the differentiation of 3s squared plus 2x plus 1 is equal to 6x plus 2. So this is our final answer. Here are some questions for you. Please do this question on a paper, take a screenshot, and you can send to the email you see in the description and we can respond to you as soon as possible. Thanks for watching, and I will see you in the part 3 of this series.